Hey guys, and welcome to this school station. Today's video, I'm going to be talking about conduction. This is from the AQA GCSE Physics 91 paper from the unit Energy and Energy Resources. Today's video, I'm going to be talking about conduction, what it is, and also an example of it. Conduction is a really important part of energy, and we also have to know about the energy transfers by heating. However, conduction is actually one of the three main ways of transferring energy by heating. The three main ways of doing this is conduction, convection, and radiation. So today's video, I'm only going to be doing part one, but there are three main parts. Part one is conduction, which takes place in solids, so the heat energy transfers only in solids. Part two is convection, where we are actually looking at the heat energy transferring in fluids, which are liquids and gases. And part three is radiation, where it only takes place in gases or through space where there are no particles. For example, when the energy from the sun to the earth is transferring, there are no particles, so the light waves and the heat waves are radiating. So those are the three main ways of energy transfer by heating, but as I said, today we're only going to be focusing on conduction. So before we actually get started with this video, you actually have to know about heat energy, because these three main ways, conduction, convection, and radiation, is basically how heat energy transfers. But what exactly is heat energy? Heat energy is basically the high kinetic energy of atoms, molecules, and ions. So the way I like to remember this is I basically have a kettle of water that is boiling. And when you actually have this over here heating, it's actually, you will be able to see that the water is moving very fast while you're heating it up. And you will also be able to see that the particles are colliding with each other and colliding with the walls of the kettle very quickly. And this is basically how the water is heating up. So this is how I like to remember heat energy, because when we're heating a kettle of water, we're basically making the water particles move really fast, which is high kinetic energy. So heat energy simply is high kinetic energy of atoms, molecules, and ions. The next thing we also have to think about is, what is conduction? So after we have known what it exactly is heat energy, we have to think about conduction now. So conduction is the transfer of heat through vibration in solids. So basically, you have to really think about this. So as I said earlier, conduction is one way of transferring heat energy, and conduction only happens in solids, and this happens through vibration. So we are going to be looking at an example later on, which will help us to understand more about conduction, how it takes place. But something else you also have to understand is that the energy transfer by conduction through a material depends on its thermal conductivity. The greater the thermal conductivity of a material, the more energy per second it transfers by conduction. So what I'm literally trying to say over here is that when you're basically when there is actually heat energy that is transferring through a solid, it will actually also depend on its thermal conductivity, and it's basically about how quick the heat energy can transfer. And that's literally about it. That's what thermal conductivity is. And obviously, the greater the thermal conductivity of a material, so the more quicker the energy can transfer, the more energy per second transfers by conduction. So that's what I'm trying to say. So we'll be able to transfer heat energy as quickly as possible through the solid if we have a great thermal conductivity. So that is the definition of conduction. So now that we've clarified what is conduction and also heat energy and how it transfers, we actually have to look at an example of conduction. So over here I actually have an example of conduction where a spoon in a cup of hot soup becomes warmer because the heat from the soup is conducted along the spoon. So for example, we just have to think about this in real life because it really helps us to relate. So for example, if we have a metal spoon, okay? We have a metal spoon and we basically are stirring it. We put this spoon in a cup of hot soup and we're basically just stirring the soup with our metal spoon. you will eventually realize that the spoon may actually be really, really hot, and it could even go to an extent where it can burn your fingers. And the reason why is because metal is a conductor. So what happens is that basically you actually have the particles from the soup, and when you're stirring, or just in general, if you leave the spoon inside the soup, you'll realize the particles actually slowly start to get into the particles inside the spoon, which is a solid. And then what happens is that the neighboring molecules are actually affected by the increased motions of the heated molecules, because when you're heating the spoon up, the particles over there start to vibrate because it is high kinetic energy, as I said earlier, because heat energy is high kinetic energy of atoms, molecules, and ions. So when you're basically getting the spoon and you're just putting it in a hot soup, you basically, the section of the spoon where you actually have left it in the soup, it will actually start getting warmer, and the heat energy will be transferring because the particles will start to move very, very quickly. And then what happens is that neighboring particles, they actually will start vibrating as well. And this is just basically how it goes. Then it just goes up and up and up until you can feel it in your fingertips that the spoon is actually warm. So just by the neighboring particles vibrating until it reaches the top of the spoon, this is kind of how conduction works. And the reason why like gases and liquids don't have conduction that much is because gases and liquids are generally poor conductors of heat, because the molecules are farther apart than are the molecules in solids, because conduction uses the vibration of particles, and in gases and liquids the molecules are farther apart, so they won't really be able to vibrate. So therefore conduction doesn't really work that much in fluids, but it's more effective in solids. So that's basically what conduction is and an example of it. So now we're actually going to go on to conductors versus insulators. So you may have always heard that there are two types of elements, I would say. There is conductors and insulators. So usually you will hear that conductors are metals and insulators are usually non-metals. And the reason why is because, for example, conductors actually transfer heat and they also transfer electricity. So for example, a copper wire, it actually is we usually use copper for our wires so that electricity can transfer quickly, because copper is a metal and it is a conductor. So therefore we usually use copper for our electricity, but conductors are good materials for electricity and heat, and conductors are usually metals like copper, steel, iron, and all that stuff, whilst insulators are usually non-metals. However, sometimes students actually misunderstand and they think that non-metals are never can't conduct heat at all, and that is actually incorrect, because insulators actually can transfer heat. So all solids can conduct heat, but insulators are really slow at transferring heat, or are not able to transfer heat properly. And this is because obviously we can see that if we have, for example, let's say a thick fabric coat on, you will see that eventually you will see that the heat energy from your body is not always going to stay, and eventually if you go outside on a snowy day and it's really, really cold, eventually the cold will get to you, because insulators do conduct heat still, but they're really, really slow at transferring heat, or are not able to transfer heat properly. And an example of a non-metal conductor, because we said conductors are usually metals, but an example of a non-metal conductor is graphite pencil, which is a carbon, because if we have a pencil, it actually has graphite inside it and it is a carbon, and this is actually a non-metal conductor. So that is basically the difference between conductors versus insulators. Conductors are usually metals, whilst insulators are usually non-metals. However, insulators still do conduct heat, but they're very, very slow at transferring heat, or not able to transfer heat properly. So now that we've actually clarified about this, I just want to quickly go through some information about conduction before we end this lesson. So metals usually have outer electrons that are not attached to any particular atom, allowing them to freely move between the atoms. So basically in metals, they usually have electrons in the outer shell, because if you guys have watched my chemistry videos, you will know that there are basically electrons in the outermost shell. And what happens is that metals, they usually have outer electrons that are not attached to any particular atom, and this allows the electrons to freely move between the atoms. So basically they're free because they're in the outside. And then when a metal is heated, the free electrons gain kinetic energy. They transfer energy through the metal. So this is basically usually in metals. When a metal is heated, the free electrons gain the kinetic energy because, as I said earlier, the outer electrons are free to move. So these free electrons, they just gain kinetic energy and they basically start moving very quickly. And this is how they basically make the neighboring particles in the solid vibrate, and they transfer energy through the metal. And last of all, insulators do not have free electrons, and so they do not conduct heat as well as metals. So basically, insulators are usually non-metals, and usually non-metals do not have free electrons in the outside. So this is why they're not able to freely move, and this is why they're not able to conduct heat as well as metals. But as I said, insulators still do conduct heat, but it's very slow, or they're not able to transfer heat properly. So that's basically everything about conduction. Just as an overview of what we have learned today, we actually understood what heat energy is. So heat energy is basically the high kinetic energy of atoms, molecules, and ions. We've also learned what conduction is. Conduction is basically the vibration of particles in solids. So this is what we have learned, heat energy, and we've also learned the definition of conduction, which is obviously the transfer of heat through vibration in solids. We have also learned the difference between conductors and insulators. So conductors conduct heat, they allow heat to transfer very quickly, and insulators do not allow heat to transfer properly because they're either slow at it or they're just not able to transfer heat properly. So I hope you guys have enjoyed this lesson. I hope this helps you. Definitely give this video a thumbs up if this did help you, and subscribe down below to the school station for more free science and maths lessons. Bye guys!